Hi, my name is Richard and welcome to my YouTube channel. Today, our discussion on mechanics will be on momentum and impulse. Today, before the video will end, we'll learn what momentum and impulse means, the relationship between the two, the unit for measuring each of them. Then, we'll talk about the principles of conservation of momentum. This will be a very interesting engagement, so please come along. So first off, let's look at what momentum means. Momentum is the product of mass and the velocity of an object or a body. It is measured in Newton seconds or kilogram meters per second. So let's say we have a ball and the ball is moving at a speed of, let's say, v, and the mass of this ball is m. We say that the momentum of the ball, okay, the momentum of this ball is equal to the mass of the ball times its velocity. So we say momentum is the product of the mass and the velocity of an object. So let's look at this simple question. They say an object of mass 8 kg is moving at a velocity of 10 meters per second. Calculate its momentum. So remember, we said the momentum of an object or body is equal to the mass of the body times the velocity. So the mass of the body is 8 kg and its velocity is 10 meters per second. So 8 times 10, that will be 80 kilogram meters per second or 80 Newton seconds. So the velocity, the momentum of this ball or the object is 80 kilogram meters per second. I hope you get that. So now let's look what is an impulse. We say impulse is a change in momentum of an object. Impulse is also the product of a force and time taking of an object or body. Now let's explain the two definitions. So let's say we have a ball. This ball, the mass, a ball of mass m kilograms. This ball was initially moving at a speed of u meters per second, and the ball increases its speed to v meters per second. Okay, so the same ball increases its speed. So now what will be the momentum at the initial speed? The momentum, remember, is a product of the mass and the velocity of the object. So the momentum here will be mu. That's m times the mass times the velocity. And here will be mv. So the change in momentum, that's mv minus mu, becomes impulse. So we say impulse is equal to, see, we can factor out m out, then we have v minus u. So impulse is just the change in momentum. Now remember also, let's look at the second aspect, which is the product of the force and time. So we say force is mass times acceleration. So an acceleration is what? Is a change in velocity with respect to time, if you remember very well. So we can substitute a here. So we have F is equal to m bracket v minus u over t. That's in place of a, I substituted v minus u over t. Now across, I'll multiply both sides of this equation by t. I'll have ft is equal to m times v minus u. Now m times v minus u, remember, is impulse. We say impulse is that. And we have force times the time again, and it is equal to that. Then we can say that impulse is also a product of a force and time. So impulse is a product of force and time and a change in momentum. I hope you get that. Now let's look at this question. They say an object of mass 5 kg changes its speed from 8 meters per second to 10 meters per second in 5 seconds. Calculate 1. Its impulse. Then 2. The force acting on the object. So now let's see how we do that. Remember, we said the impulse is a change in momentum. So we say impulse is equal to m bracket v minus u, where u is the initial velocity and v is the final velocity. Now our m, or the mass, is 5 kg. The final velocity is 10, so 10 meters per second. And the initial velocity is 8 meters per second. So you can say the impulse will be equal to the mass, which is 5, times velocity, the final minus the initial, 8. So see 5 times 10 minus 8 is 2. 5 times 2 will be 10. So 10 kilogram meters per second. Now, that's the first aspect. The second aspect, they say we should find the force acting on the body. Remember, we said impulse is also the product of a force and time. And we said that force times time is equal to the change in momentum, if you recollected. And the force, the time of the object, the time taken by the object is 5. So we can say t is equal to 5. So F times 5 is equal to the change in momentum is 10. So 10. So 5F is equal to 10. On divide both sides by 5, our force will be equal to 2 Newton. So the force acting on the object is 2 Newtons. I hope you get that. So please pause the video and try to see if you can solve the second question. You say, what constant force acting in the direction of motion of a particle of mass 2 kg will increase its speed from 4 meters per second to 20 meters per second in 4 seconds? So they're asking us to calculate the force. So remember, the force times time is equal to the change in momentum. So the time is given to be 4 seconds. The mass of the particle is 2 kg. The initial velocity was, we increase its speed from 4, so 4 meters per second. And the final velocity v is 20 meters per second. So now, we can say that the force F times time 4 will be equal to 2 times the velocity, the final velocity 20, initial minus 4. So what do we have? We have 4F will be equal to 2. 20 minus 4 is 16. I can divide both sides by 4. My force will be equal to 4. 16 divided by 4 is 4, so that will be 2 by 4. Then my force will be equal to 8 newtons. I hope you had 8 newtons. So let's see our next question on this. We say a body of mass m kg changes its velocity from 10 meters per second to 25 meters per second in 2 seconds. If the force acting on the body has magnitude 5 newtons, we should calculate the value of m. So this is on impulse and momentum again. Remember, the product of a force and time is equal to the change in momentum. So the force was given to be having magnitude of 5 Newton. The time taken was 2 seconds. Then the final velocity was 25 meters per second. And the initial velocity was 10 meters per second. Now we need the mass of the body. So we know Ft is equal to m bracket v minus u. So we have 5 times 2 will be equal to m bracket. Our v is 25 minus 10. So 5 times 2 is 10 equal to 25 minus 10 is 15. So you can say 15m is equal to 10. We'll divide both sides by 15. We'll get m to be 0.67, correct to 2 decimal places. So we can say that the mass of the object is 0.67 kilograms. Okay, our next stop is principles of conservation of momentum and its application. So we said the principle of conservation of momentum states that in the collision between two bodies, the total momentum before collision is equal to the total momentum after collision. So how do we put this into practice? Let's say we have a car A and the mass of this car is m1. And this car is moving at a speed, let's say u1. And we have another car, let's say B, and the mass of this car is, let's say, m2, and it's moving at a speed of u2, and this car happens to crash or hit the other car. Now, two things happens, but let's look at the first scenario first. Two things will happen if they crash. So now, maybe after collision, this car A of the same mass m1 happens to move at a speed, let's say v1, and the B happens to move at a speed, let's say v2, the same mass. Then we say before collision, the momentum of this car A will be m1 u1. Remember, momentum is the product of mass and the velocity. And this one, the car B will be m2 u2. Then the total momentum before collision, we say m1 u1 plus m2 u2. So we say m1 u1 plus m2 u2. Now, after collision, this car happens to move at this speed. So its momentum there after collision will be m1 v1. And that of B will be m2 v2. Then after collision, the total momentum will be m1 v1 plus m2 v2. So what is the principle of conservation of momentum telling us? It says that the total momentum before collision, which is m1 u1 plus m2 u2, will be equal to m1 v1 plus m2 v2. I hope you get that. Now listen, after collision or before collision, these cars might have been moving towards the opposite direction. Maybe this is coming from here and this is coming from the other direction. When they are moving in opposite direction before collision, then we say that we negate one of the velocities before collision. So when we negate this, we can say m1 u1 plus negative m2 u2 will be equal to m1 v1 plus m2 v2. So we can have m1 u1 minus m2 u2 equal to m1 v1 plus m2 v2. So we're able to discover two equations. That's the total momentum before collision is equal to the total momentum after collision when the cars are moving in the same direction. So we say m1 u1 plus m2 u2 is equal to m1v1 plus m2v2. And we said, remember, if the cars are moving in opposite direction before collision, then we negate one of the velocities. It can be this or that. So we say m1u1 minus m2u2 is equal to m1v1 plus m2v2. There is another thing you must remember. If after impact, the cars can move with the same velocity. When they move with the same velocity, then our first equation, we can have m1u1 plus m2u2 equal to, since the velocity are the same, we can say m1v plus m2v. What happens? We can factor out. So we say m1u1 plus m2u2 will be equal to m1 plus m2 all times v. So when the cars after impact move with the same velocity, then remember this will be our equation. Now, when they are moving in opposite direction and after impact they move with the same velocity, then we can have m1u1 minus m2u2 is equal to m1 plus m2 times the velocity. That's the common velocity. I hope you get that. Now we'll take some sample questions and we'll put all these things into practice. So now I want to see some sample questions on the principles of conservation of momentum. First, they say two bodies of masses 4 kg and 5 kg move with velocities 6 meters per second and 2 meters per second respectively in the same direction collide. After collision, the bigger mass moves with a velocity of 1.2 meters per second. We should find the velocity of the smaller mass. So let's put this into diagram first. So let's say this is the first body. The mass of this body, let's say, is 4 kg and is moving with a velocity of, the velocity is 6 meters per second. So 6 meters per second collide with another body. Maybe that body is moving with the mass of the body is 5 kg and it's moving with a velocity of 2 meters per second. So after collision, they say the smaller mass. So which is the smaller mass? This is the smaller mass. Move with. So after the collision, they say the bigger mass rather moves with a velocity of 1.2. So we can say this is 1.2 meters per second. Now we don't know the velocity of the smaller mass. That's why they're asking us to find. Remember, the bodies are moving in the same direction. So we can say our m1u1 plus m2u2 will be equal to m1v1 plus m2v2, where u is the initial velocity and v is the final velocity respectively of the two bodies. So let's say this, the momentum here, that's for this will be 4 by 6 plus, that's before collision, then this will be 5 by 2 and to be equal to, what's the mass? The mass is 4. We don't know the velocity there, v1, plus the mass here is 5. Then the velocity after collision was 1.2. So 4 times 6 is 24. 5 times 2 is 10. And to be equal to 4v1 plus 5 times 1.2 is 6. 24 plus 10 will be 34. And to be equal to 4v1 plus 6. So we can say 34 minus 6 is equal to 4v1. So 34 minus 6, that will be 28, equal to 4v1. On divide both side by 4, we'll have v1 to be 7 meters per second. So we can say that after collision, the smaller mass move with a speed of 7 meters per second, or a velocity of 7 meters per second. I hope you get that. So now let's look at our second question on principles of conservation of momentum. It says a particle of mass 6 kg moves with a velocity of 4 meters per second. It's in vector form, and collide with another particle of mass 4 kg moving with a velocity of 12 meters per second. If after collision they move with the same velocity, find correctly to 2 decimal places the magnitude of their common velocity. So now let's put this into perspective again. So let's say this is the first particle and the mass is 6 kg. It's moving with an initial speed of 4 meters per second and happens to collide with another body moving with another body of mass 4 kg moving with a speed of 612 meters per second. So now after collision, they move with the same velocity and they are asked to find that velocity. So remember, the total momentum before collision is equal to the total momentum after collision. So we can say m1u1 plus m2u2. In this case, since they have the same velocity, they move with a common velocity after collision, we can say m1 plus m2 times v, if you remembered. So now our m1 here is 6 times our initial velocity of the body 4, then plus our m2, which is 4, times the initial 12, will be equal to m1 6, m2 4 times our common velocity. So 6 times 6 will be 36, 6 times 4 will be 24, plus 4 times 6, 12, then 4 times 12 will be 48. So our 4 times 6 here will be 24, please. Equal to 10, 6 plus 4 is 10. So 36 plus 24 will be 60. Then 24 plus 48, that will be 72, equal to 10v. So when we divide both sides by 10, can get v to be equal to 1 over 10 times 60 times 7, 72. So 1 over 10 times 60, that will be 6. 1 over 10 times 72 will be 7.2. So that will be our velocity. However, the question says we should find the magnitude of that common velocity. So the magnitude, remember how to find the magnitude of a vector, will be equal to the square root of c squared plus 7.2 squared. C squared is 36 and 7.2 squared will be 51.84, correct to 2 decimal place. And we add this to this, we'll get 87.84. So I will simplify this. We'll get the magnitude of velocity to be 9.37 meters per second, correct to 2 decimal place. I hope you understand. So the common velocity of the particle, of the two particles, is 9.37 meters per second. So let's solve our last question on this, on principles of conservation of momentum. Before we do that, please subscribe to my YouTube channel, like my videos and comment. Your comments keep me going, so please keep your comment coming. Now pause the video and try solving the question. After that, you compare your answers with mine. So they're going to say two masses, 20 kg and 50 kg, moving with velocities 25 meters per second and 20 meters per second, respectively, collided. They move together after collision. Find the common velocity if they were moving in A, the same direction, B, opposite direction. So remember, when we're having the same direction and opposite direction. So let's look at the first instance, A, when the two bodies are moving in the same direction. Then we can say the first body, which is moving with 20 kg, goes like that. Since they are moving in the same direction, the second body, which is 15 kg, will also go in the same direction. This body was moving at a speed of 25 meters per second, and this one at a speed of 20 meters per second. So this is before collision. Now they move together after collision with a common velocity. So the velocity will just be v. Remember we said the total momentum before collision is equal to the total momentum after collision. So m1 plus m2, since they are moving with the same velocity, times v, if you recollected. Now what's our m1 here? Is 20 times 25 plus our m2 is 15 times 20 will be equal to 20 plus 15, that's m1 plus m2, then times our common velocity. 20 times 25 will be 500. 15 times 20 will be 300. Then it will be equal to 20 plus 15 is 35. Then V. 500 plus 300 is 800 and is equal to 35 V. Now divide both sides by 35. Our V will be 22.86 meters per second. So their common velocity, if they were moving in the same direction, that's the A aspect, will be 22.86 meters per second, correct to 2 decimal place. Okay, now the second instance, if they are moving in opposite direction, what will be their common velocity? So the first body, remember, the mass is 20 kg. If it is moving in this direction with a velocity of 25 meters per second, then the second body, which is having a mass of 15 kg, will move in this direction, opposite direction, with a velocity of 20 meters per second. Now they say they move together after impact. So we can say this with a common velocity v. So we said before impact, then after impact. So since they are moving in opposite direction, remember we negate one of them, one of the velocity. So we say m1 u1 minus m2 u2 will be equal to, since they are having the same velocity, then we can say m1 plus m2 times that common velocity. Now what's our m1? Remember, is 20 times 25, which is the initial velocity of the 20 kg body. Then our m2, which is 15, times the initial velocity there, 20, will be equal to the 20, that's the mass of the first, plus the mass of the second, 15, times the common velocity. 20 times 25 is 500 again. 15 times 20 will be 300, and to be equal to 35 V. 500 minus 300 will be 200, and to be equal to 35 V. Now divide both sides by 35. We'll get our common velocity to be 5.71 meters per second, correct to 2 decimal place. So this is the common velocity if they are moving in opposite direction. I hope you understand. We'll end it here today. Please remember to subscribe to my YouTube channel and share and like my videos. Until we meet again, my name is Richard.